First, what is a radical? It is a symbol used to represent the root of a number. The most common radical is the square root symbol, but it can also be used for cube roots, fourth roots, and so on. And what is the square root of a number? It's basically finding the number that when multiplied by itself equals the number inside the square root symbol. For example, the square root of 9 is 3 because 3 times 3 equals 9. The square root of 16 is 4 because 4 times 4 is 16, and so on. Therefore, when we're talking about simplifying radicals, we're talking about making square root expressions as simplified as possible. Here's what we mean. Many times the square root of a number is not a nice and pretty whole number. The square root of 5, for example, is 2.236067998, and the numbers keep on going. Because of this, mathematicians prefer just writing the square root of 5 and leaving it as is instead of writing all those numbers. With this in mind, there are numbers that can actually be simplified a little bit more before calling it a final answer. Let's look at the square root of 8. The answer is 2.828422712, and the decimals keep going forever. Therefore, it's easier just to write the final answer as the square root of 8. However, we can actually simplify this a little more. We will explain the process in an upcoming video, but examples like this have a perfect square that can be simplified out of the radical. Here's what we mean. The square root of 8 is the same as the square root of 4 times 2, and this is also the same as the square root of 4 times the square root of 2. 4 is a perfect square, meaning 2 times 2, and because of this, the square root of 4 simplifies to 2. Therefore, we can now write 2 times the square root of 2 because we just calculated the square root of 4 and no longer need it inside the radical. Next, the square root of 2 does not simplify to a whole number, so we leave it inside the radical, and the final answer is written as 2 square root of 2. This is what we mean by simplifying radicals, and again, we'll explore this more in depth throughout this chapter. Finally, what does this concept have to do with Algebra 1? How does it fit into the course, and why is it in the middle of the quadratics unit? I'll be real, this concept does feel a little out of place. However, it is helpful to learn it in Algebra 1 because it is important for geometry, Algebra 2, and other future math courses. In addition, it does fit a little bit with our quadratic unit because we will learn about a solving method called the quadratic formula in the next chapter. This method includes a radical inside the formula, so it's helpful to learn more about radicals before learning about the quadratic formula.